Okay, we are live. Hello. 11:20. Got a good chunk of time now to start working on stuff. Um, the plan for today is to implement Muon. In fact, let's go tweet that. This. Cool. Go do this. Oh yeah, also I did so this did not actually sync correctly, annoyingly enough, but we have this and yeah, this curve is like oddly shallow. Here, let me see. This thing is so shit. We'll try Wannabe again, I think. See if it's gotten better, but it's just so shit. This used to be better. I literally can't fucking hit enter on this. Yeah, so this was the one that drops off, like, immediately. Okay, so yeah, this was the previous best run. It's kind of weird how this has this same shape to it. I can't think of any reason it would be like this, but whatever. We will have to run more experiments, I suppose. It's also interesting to me that this learns quickly as well. To be fair, I think this is... Yeah, this is not multi-GPU, so it's possible that it's like some weird thing with that. Alright, let's start on Muon. Enough of this, enough of this, enough of this. All right. Here we go. This is what we're doing today. We're doing this port, Keller's implementation, most likely. We need a few other resources available here. We need PyTorch's muon. Oops, wrong browser. I'm not signed into this one. Welcome. Yeah, so right here, they define, they've got muon in Python. So this is going on my other monitor probably. And then what we'll do on the stream here so we'll include muon here. Like this. Cool. Now we have to figure out, I actually think we probably need well, I guess we need all these params. Muon options. Deserialized torch args. So we have learning rate. Weight decay. Momentum. We can just match this, right? And I think we use this one here. Got inspired by a Puffer constellation, writing CFD with CUDA and ArrayLib plotting. That's awesome. That is awesome. For sure. So something like this. Yeah, there's gonna have to be like a hierarchy of approximations. I also don't know how fast it can be made with just good code. Hey, Convert. Welcome. Weight decay. Not bad, right? What do you use to combine all the chats? Restream. See what else is in here. Okay, so we have to figure out these state variables. What this thing actually keeps. Also, how does Torch do defaults? I don't see defaults anywhere, do you? To figure that out. Hmm. You know, this is actually probably something that I can do. Holy comments, bro. We want the Muon class wherever it is. Momentum buffer. How many buffers does this thing have? So there's Muon momentum buffer. It looks like there's only a momentum buffer, right? Am I wrong here? There's just one momentum buffer? It was easy. Well, no, Convert. It's the fact you have it backwards. So it's not let's make the problem easy so that it can train in less than 4 minutes. That's not what we're trying to do with Puffer. It's just that we make Puffer so good that it can solve a lot of typically easy problems in less than 4 minutes on random people's computers. If you have a problem that's naturally harder, then it's just going to be naturally harder. But I suspect that we can probably even make that version solve in less than 4 minutes. Like, ultimately, the point of Puffer is not to solve easy problems super fast. It's to make RL super fast, so easy problems are solved basically instantly, and we can actually still solve harder problems relatively efficiently as well. Yeah. Like, we can kind of just do both. Move on. Looks to me like there's only one there's only one buffer. Exp average. This doesn't use exp average, right? It just has momentum. Yep, just one momentum buffer. We don't have this AMS grad, I don't believe. Okay, and then is this in step? Yeah, this is in step. Okay, so we are actually at the core of it. Is there anything else to do here? Load. There's just some serialization. This is basically just dumb pattern matching, no? Out. Don't need this. Oh, but this is going to be the actual core logic. So, yeah. So here what we do is step. Then this calls muon. Inside this. And then in this one, it's just one loop. Cool. Of course, even the C++ shitty language is better code than the Python. Not surprising. Just P param. Very like coding live. I do it every day pretty much. I do all my dev live. It's kind of watch the field of reinforcement learning advance and become fast insane. Just live. So the idea here, this code sucks, but I'm writing it to Torch standard because I'm thinking I'm going to PR it to Torch. And then what I'm going to do is I'm going to have this as our baseline. So I can use Muon and I can use Atom together as our baseline. And then probably what's going to happen is that this thing is going to become a bottleneck because Puffer is so fast. So then I'm going to have to write a fast version of this. But at least I will have like a PR'd version, right? Like a tested solid version to compare against. That's the idea. Welcome, Liberty. I wish I did not hear the stupid insurance jingle in my head every time you join stream. Yep. Okay, so this is weight decay done, right? We do not need this. Do not need this. Do not need this. We do need momentum buffer, right? So momentum buffer dot lerp grad and 1 minus momentum. I don't know why I shouldn't just be able to do it like this, right? If Nestrov, else buff. So update is what, a tensor? Where's grad? p.grad. Oh, no, we have grad. Yeah, I could not put up with that, man. I like peace and quiet far too much. Okay, so now we have to do update. We have to do this thing. So something like this, right? And then we do adjusted learning rate. Add cdiv. I think it's just p dot mul, one line is learning rate, and then add the update. This. And this is muon, other than the hard part, which is right here. Actually, let me just go tell the, oops. Where is... What the fuck? Where's... Oh, there it is. They changed all this shit. There. Alright, what the hell is this? Mamma mia. That is some math. Oh yeah, what's this as well? Oh, this is Keller's implementation, right? So we wanted to base this off the Torch implementation. What's that group? Some random researcher group. I have a few of them. I don't know. It was funny. I went to a random meetup with them in SF, and it was like, basically one guy from every lab. I met Keller there, and Keller was actually... He was the only person to ever give me a satisfactory answer to the, like, the whole AI safety bullshit question. That was cool. Jim? No, Keller, Jordan. The Muon guy. It was pretty funny, because I basically told him, like, hey, I used to think that your entire line of work on optimizers was just total bullshit. and then Muon actually worked, and I was completely wrong. Good job! It's a major addition to our library now. I mean, it's like the most recent example of me just being absolutely fucking wrong on something. It's kind of funny. Well, let's do this one first. This is easy. Okay, so adjust learning rate takes learning rate, and then adjust learning rate function, blah, blah, blah. What did I call this? Match RMS Adam W. Alright, so, whoops. Can my editor not, like... I would like to know how to avoid it, like, doing the auto-comment bullshit. I basically never want my editor to type characters for me like that. The only exception I can think of is the auto-indent. Oh, wait, there's 3 of these? Ah, that's annoying. It should be std string or whatever. Standard string. Okay. Wait, isn't this, like, weird as hell? How the fuck is this supposed to work? Isn't this implementation kinda shit? Adjust learning rate function. Original match. Wait, it can be none, original, or match this, right? So it could be none, or it can be this, or it can be this. So this is never used. Oh, so basically it's bullshit. Gotcha. I gotcha. Adjusted LR. Ooh, you see this? This is tricky. There are two of them. Okay, so we just do auto adjusted LR. Which is what, double? It's probably just double, right? And then this is gonna be where, well, this is not it either. Param.shape. Auto A. This. Like this, yeah? Oh, and it's gotta be LR times this, right? Adjusted ratio. This is ratio. Sent proposal stuff. I replied to that. Hang on. Let me get this off screen. Oops. Phone number. Okay. That's fine. Just replied there. Yeah, so the plan is if we get this done, and signed, like, in the day today, then I will start working on this tonight. And, yeah. Our normal terms are, like, we normally do half upfront, half on delivery. If that works, that's ideal. If not, because I know it's, like, based on the org information, there's probably some administration around that. So in either way, it'll be before we hand you the deliverables, right? Probably after we show demo. If you can just do normal half upfront, half on delivery, that's way easier. You know, we're a bootstrap startup as well, and we typically don't finance cash flows. Other than that, the content of the stream until then for today is porting Muon to C++ because Torch did not add it to their backend. Yep. So basically, billing that way, it means that I can never I basically, if I do it that way, I can never owe people money that I have not been paid, if that makes sense. So that's why I do it that way. Mm-hmm. Yeah, and then we'll see with this one whether Spencer and I both do it, or whether I just decide to like hammer this out all weekend, or what we do about it. But it'll be a fair bit of work either way. You're asking for some doable but not exactly trivial things in that timeline. Okay. I probably should update our website with something about our sim pricing at some point soon. But frankly, the expectation is it'll probably go up a little bit with Puffer 4. Because, I mean, it's just going to be so much better. Like, what you can get in Puffer 4. I mean, already some of the tools that we're using from Puffer 4 on professional work is just, it's so cool. And we already have the plans for Puffer 5 as well. Like, RL's going to be in a really solid spot soon. Newton Schultz. Okay, so this is the annoying op that I have to implement, right? Yeah, this is the giga annoying operation. I will respect their API here. And I will keep this syntax. And this is over one, so this is tensor, 0th power Newton Schultz. And then this is going to be tensor grad. Couple coefs. Yeah, like this, right? Number must be less than 100 for computational efficiency. That's such a weird thing to do, but okay. Isn't it torch check? Ugh, what? It does the grad and B float 16? Like, by default? Really? That's bizarre. Well, now I know why heavy ball was such a pain in the ass. But wait, it doesn't fucking cast it back. Huh? What? That's them. It's bizarro. Grad size. Cool. Orthograd equals grad dot 2. Okay. Load 16. Do like this. Can do this like this, and ortho div orthograd norm clamp ups like this. Okay, so we take gram matrix. It's a matmul orthograd. So grad.t. And then we do gram update, which is going to be add gram matrix, gram matrix, gram matrix. See, I'm guessing that's the same API. So orthograd. And should be basically the same API, yeah? The only thing is a little weird is beta equals alpha equals. Just go double check the API. Beta equals alpha equals. Okay, so I think that this is fine with the way optionals work. Right? Beta, alpha, beta. Yeah, this is fine. And then we do. We also need to do torch tensor. Tensor ortho grad. This. Good. And then we do ortho. Yeah, just transpose. Cool. So that is in about the same amount of code as the Python version. C++, 0th power Newton Schultz. I have no idea what the math is. That's not entirely true. I took convex opt. Only course I ever failed. I intentionally took the course as a freshman knowing I was going to fail it. But I learned some stuff. I'll tell that fun story real quick. I'll tell the convex op story real quick. Let me get some coffee, then we'll continue. Oh, and let me get my bench set in. Hola, hey Henry. Let me get my bench press set in as well. Bench press? Yeah, I think that's what I'll do today. For 9 isn't terrible. Alright, so convex op story. You might have noticed that I might just be a little bit of a contrarian for its own bloody sake. Just a little bit, right? So I got to Stanford at 18, peak blunder years, and one of the first things they told me is, oh, well, Stanford students don't know how to fail. Like, most of you have never failed anything, so you don't know how to fail. So I said, okay, challenge accepted. So I decided to take my normal course load plus 2 grad classes in my winter term, and I decided for one of them to just take the hardest class I could find, which was convex opt. The other one was like some distributed computing thing. I actually passed that. But yeah, the convex opt was just brutal math that had no business whatsoever taking. And I would go there dutifully at 8 in the morning. I'd bike through the rain to get there. I'd have, I don't know, my mug of tea and some toast that I'd normally get in the morning. Just sitting in the front row. I'd occasionally answer stuff. I had a good time. And, I think the professor asked at the start, like, oh, are there any undergrads here? Are there any juniors here? Are there any freshmen? Are there any sophomores? Any freshmen? And he, like, looks at me and my one other friend that I dragged into it. Like, okay, you guys are nuts. I don't know what you're doing here, but cool, I guess. That course has a 12-hour midterm and a 24-hour final. And yes, they are actually written for that amount of time. I barely got anything right in that whole course. But, I tried and I learned some stuff. So at the very least, I have some idea of, at least at a high level, what is going on here. Don't ask me any of the details, though. 24 hours, how's that work? They give you the final. They say, it's due in 24 hours. Come back with it completed. Don't cheat. And it actually takes you 24 hours to do it. That's how it works. Oh yeah, my friend was super mad at me. He actually passed it as well, because he was a math guy, right? Nah, I still know him. He went to my high school, actually. He's like the one other guy from my high school that went to Stanford that year. I had all sorts of fun stories. Like, one time, I think in my freshman year, I got, like, way too drunk. And he said, all right, dude, you gotta go home. Like, and, like, I called him or whatever. It's like, all right, you gotta go home, dude. You're way, way too out of it. Like, I'm gonna come get you. And I said, no, you're not. And he said, yeah, I am. So I said, I bet you I can implement K nearest neighbor in one line in this state. He's like, bullshit. So I gave him a one-line tensor implementation of K nearest neighbor. And he went, oh, that's actually right. Fuck, I never thought of that. All right, I guess you're good. Have fun. How'd you get into MIT for a PhD? Because I'd basically been doing research full-time since I got to undergrad. Like, I did my first publication solo was sophomore year, and then I did a stint at OpenAI. I met Philip there. Philip, I worked with him there for like 6 months. He went on to become a professor at MIT, so I followed him there. So yeah, I've basically just been doing research constantly for a while. All right. That's enough fun stories for now. We're gonna get Muon done today. Ah. I know there's some parts of undergrad that were like really cool, and some parts that were just super depressing. That's basically the full logic of it. I think we need to do serialization and debug it. What are you using PufferLib for? Well, I'm developing PufferLib, right? Hey, Yannick. I'm developing PufferLib right now. So, I mean, we use it for a few client jobs, like a few different sims. But mainly I spend the majority of my time like building the library, making RL faster, evaluating on tons of M's, working on core algorithms. So I'm really doing core tech most of my time. And then when companies want custom sims where they want their problem solved using our tools, then we charge a premium for that, right? Yes, so there is no, it is implemented at Henri. So Muon was a major component of Puffer 3, but it was heavy ball Muon. It wasn't our own implementation of it, right? It's just something we use. And then for Puffer 4, I was trying to move it to the PyTorch Muon because PyTorch recently added Muon, but they didn't add it to their C++ backend. So now I'm adding Muon to their C++ backend for them, and then we're going to have it in C++ as well. Muon is really good. Like, Muon is actually really good. Very confident in that. Doing RL forever since undergrad. 2017, 2018, something like that. I worked on the same project as well the whole time through there, through my whole PhD. Was building neural MMO. Really, like, I've spent the last near decade just trying to make RL work in more complex and interesting settings, and then building tools to try to make that faster and easier. That's kind of my whole gig. Low resource. Yeah, you do end up having to use Atom with it as well, Henri, for 1D params. Yeah, but Muon is very good. It's not as good for small batch training, but for large batch training, it's like no overhead, and it's just better. It's really good. It's preconditioning, but no, I don't know the details of Atom versus Muon. the intuition that they always draw you is it's like you normalize the scale of all your gradient directions so that if you have a like narrow long bowl surface, you don't bounce around back and forth on the narrow axis. That probably is total bullshit because that's not like that intuition is not particularly useful oftentimes in high dim spaces. But I mean, the actual truth of it is you need to understand the math, and I don't understand the math well enough. I'm not an optimizer researcher, right? I'm really just using this, and I'm doing better empirical validation of this than anyone else is in RL. But no, I do not understand the details of precisely why the fuck this thing works. Cool. Aha, so here are our options. Well, I like to understand most of the things in here, but like there's so many deep rabbit holes on things to understand. Like this is one that for now I'm fine kind of just using. Yeah, I'm pretty much fine just using this as is. Just for the time being at least. And then we need the NS coefs. Weight decay is on by default. Kind of weird. This. We don't need to check the betas. I think this is good, right? Yeah, let's see how this does. So we have, oh, and let me go check one email as well. Oh, they have not replied. Cool. Yeah, so now what we have to do is get this to compile and get this to optimize. Kind of cool, though, that it doesn't take that much work. It takes an hour when I'm fresh to get a draft of Muon. Can I? Let me go check something. I actually don't understand how namespaces work for this. I thought, though. I thought so. Alright, Muon. Hard to get singular values. Hmm. Muon options has no member apps. That is bullshit. Yes, it does. Wait, how does this thing work? Did I misread this from Adam? No, it's like this. Oh, maybe it's up higher. No? Oh, you didn't do epsilon here, dummy. Did not do epsilon. I don't know how I missed that. Learning rate, weight decay, momentum, Nesterov, coefs, eps. There we are. Cool. Wait, did this guy not get? This guy didn't get it. This guy didn't get it. This guy just unironically didn't get it. That's funny. I tried using Cerebras. They hope it's open source models. Because it's fast, Honore. So the thing with Cerebras, this is their thing. They're not a models company. They make this. Yeah, that's one chip. And then they serve models on this big chip. So it serves the models really, really fast. So I don't have to sit here waiting while I wait for the fucking model, right? It can't be wait for the model, wait for the code to compile, attempt to try a thing, you know, get it wrong, wait for the model, wait for the code to compile. You're just not doing anything. You know, you may as well go do something else if that's your dev loop. Speed's important. Or undefined symbol. I probably need to include the source, right? What'd I do? Eh. Ah. I see. Whoops. Hello, Jess. We are porting Muon to C++. STD tuple size. Bleh. Deck type. What the f- Are you shitting me? You can't get tuple size? So disgusting, man. Let me see how Torch did it with, Oh, actually, you don't need to do this. Duh, because it's C++. It's already guaranteed to be this type. Cool, we can just get this check. It should be mu minus minus, honestly. The C++ is awful. This is like a terrible language. You should feel bad for liking it. Go double check the muon source. This is Keller's implementation. Where's the PyTorch implementation? There. Orthograd. Yeah, this is fine. This is totally fine. We don't want this. We want getting somewhere. Momentum. 1 minus momentum. Buff equals. Where's momentum? Oh, momentum is the arg, right? Buff. Buff. Okay, and now we also need momentum, right? If Nestorov? Can we not do Nestorov? Is this a bull? Nestorov is a bull, I'm dumb. Nestorov. And let's go fix Nest. Oh, this is right. How large is your monitor? 27 inches. (1440p) 27 inch. Tends to be optimal for me. Honestly, the one feature that I actually miss from Python in my low-level dev, probably more than anything, is just having named parameters and defaults. Is there any downside to doing that? Especially in structs, like, can I please have defaults for a struct? Would be very nice. It's so easy to compile, like, to do that as well, isn't it? Audio is gone? I think it's still going through on my end. Anybody? Yes? No? Yes? No? Audio's good on YouTube. Thank you. Audio's still here. Cool. It's funny how all the lurkers come out when you just do an audio check like that. Welcome, everybody. Ooh. Double. Double. Pythonism. I know nothing about RL or CPP, but I feel like I'm learning infinite. This is amazing. Well, C++ is awful. Like, utterly awful. I hate that I'm doing this. I'd way, way, way rather be writing C. I could do this exact same thing in C, and it would be simpler and shorter. But if you are new around here, I do have some formal educational content as well. Oh, hey, it's 23K. Thank you all. These two articles on X are like my two highest rated pieces of content. I put a lot of effort into them. They contain my best advice in programming in ML and my best advice for RL, all in one spot. And it links you to a ton of other resources as well, like easier to digest resources as well. Okay, cool. So this compiles now. What on earth is this? Okay, compiles. Using. Born in Solus. It's always so weird when it's like use C++ flit to demangle, and then it just like guesses the outcome of this operation and says, "Oh look." Ugh. Can I just like comment these serialization methods for now? Can I just do this? Oops. Do you feel like... No, that's definitely not true. I'm not doing what I'm doing because I think LLMs have plateaued and aren't going to get any better. Like, that's just stupid. I'm doing this because it's like a fundamentally different mode of progress, and I can kick ass on problems like on my home servers here that LLMs are just never going to be able to do. Never a big word. Okay, so if I give a language model a fiddly optimization problem where intuition from language doesn't help you at all, and humans can't remotely solve the optimization problem at all either, What does having a whole bunch of parameters trained on text get you? Like, the only way it will solve the problem is by writing the code that I'm writing now. It's not going to just, like, guess the outcome of something that needs to be simulated, right? I mean, you can even prove this in some cases. Like, you can just construct computationally irreducible problems. It's usually not fully the case that it's that, but, like, it's still, you're not guessing the outcome. Well, we can just work on, can I just go get torch? I think we have to go clone torch. And fork torch, don't we? Well, never done this before. Kind of crazy that it has 25k forks. Okay. What the hell? They use Conda as well? Ugh. Standard VN, okay. I'm gonna just commit this just in case real quick. There. Cool. So now I don't have to worry about losing stuff. I have PR. We are attempting to make a PR to PyTorch. Apparently not. Well, we don't need that anyways. We're adding mu onto it. Which conda? Okay. Well, the idea is that we're gonna just PR it, right? And then we can just have it in a nightly. If they'll merge it on us. Well, what's PufferLib? PufferLib is open source, my guy. This is the original Python. Yeah, that's funny. The PR is for Muon. Holy hell, is it literally gonna take this long? No, it'll cache, right? They got like a proper setup for this. This being indexed, so I gotta go to here. We can actually start on this. They only implemented it in Python, Jess. They didn't bother to do it in C++. This shit takes forever to build. No CUDA. Oh, barely any CUDA. It's kind of sad. Yeah, this is just not true. Slow as fuck. Well, this is gonna still build for a while, so I'm gonna go use the restroom and do a couple sets, I guess. And then we will continue the contributions. Yo, PyTorch. You want to compile this century? My guy. Holy. Ooh. Not name a type. Should name a friggin' type. Well, I mean, we can do, Oh, is this thing just gonna start building finally on the left? That'd be nice. So annoying. Yeah, it's like you really can't, you kind of just have to wait for Torch and test it from there, unfortunately. I mean, we'll keep this here for now, but like... Optimizer. This is just like super obnoxious. Okay. Well, we'll just have to test it from there. Heh. Funny. This is not just learning rate schedule. I think you're just plotting a step learning rate schedule. Let's try though. Yeah, no, that's brain dead. Oh yeah, Google, we have such good engineers. No. Come on, we're almost done compiling this, right, Torch? Right? I really just want to have Muon done today. That's kind of all I want to have done. We're going to compile the last eighth of this fast, or we're going to take forever? Oh, hello, Kyung. How nice of you to drop by. 231N. Yeah, go look at whatever the latest lectures are by either Carpathy or by Justin on YouTube. And no, it's not outdated. I did the wrong thing. Fix my website, apparently. Jump in Discord sounds good to me. Voice. Oh, there we are. Hello? This thing on? You're muted. This thing on? Can't hear ya. Ooh, 2 PRs. Holy moly. Okay, you've been busy. Alright, this one is nice and small.
Hi.
Hey, how's it going? Now I hear you. You're on stream as well. What's up?
Yep. You know. Yes, I've been busy.
Yeah, this is awesome, man. Like, it's great to have some smooth test downs, and we have a fair bit of stuff to test out. As you can see, I've been just grinding the new low-level backend.
Yeah, you need a good in for evaluation for sure.
Yeah, yeah. I mean, we have neural MMO, but it's kind of too hard. Like, it takes too
Yes,
long.
it's too hard, too long.
It's a good stretch, Env. Like, yeah.
But people are very they like new to it, like so. Well,
Yes, we're gonna
so
have a lot of stuff done pretty soon, I imagine. But yeah, I'm working on
2048 is
PRing Muon, as you
people
can
are
see, and
it's so.
we can do this while this compiles. So let me see what you've done.
All right.
All right, you just moved this around. You added a min learning rate for whatever reason. Cool.
I mean, that was a real issue because like
Was
when
it?
I run for 5 or 6 billion,
Mhm.
like it didn't train for like last 20% of the time. So
Mm, but then you have to sweep both of them annoyingly, right? Like you have to make sure
uh
that it's like min to max or whatever.
I don't follow. What do you
Let
mean?
me see. Did you add this to sweeps or no?
Mean running rate?
Yeah.
I haven't. Yeah.
Okay, because that'll break things, right? Because then it can set min greater than max.
Uh, wait. So the X is little out of sync, but now you are looking at the hyperparam, mean,
Yeah.
max, and mean.
So if you have min learning rate greater than max learning rate, which can happen if you add min learning rate as a variable to the sweep,
Hmm.
then the sweep can set the min bigger than the max, which will break stuff, right?
So I haven't tested that, but it goes directly to the error scheduler, and I
Well,
don't
it's
know
just set
how
to 0 right now, so it's the same thing.
Yeah, default is 0. Yeah, so
Yeah.
that's like rarely use it when you really need it, especially
Yeah.
for longer training. But I think under 2 or 3 billions, yeah, setting 0 will work fine.
I think the way that it should be set, frankly, Kyung, would be we set we would set it to be the number of orders of magnitude or like factors of 2, something like that, of the reduction. So it could be like, it gets swept between uh like 0 and 3. So anneal learning rate, like 0 would be it doesn't anneal, 3 would be it gets to be 1,000 times smaller than the start, and then it'll never break. And then that'll actually let us sweep the annealing more effectively over M's to see that as well. That's probably how I do
Yeah,
it.
yeah, like so set it as a percentage of the input running rate. Like that's what you mean, right?
Yeah. All right, I just had 2 different clients spam me at the same time. Um,
Business is booming, huh?
yeah, it's not. I mean, it's honestly for the complete lack of effort that I put into like advertising and trying to grow the business. It's pretty good. Um, I think
That's
it'll get
cool.
bigger when I actually focus on it, but for the most part, at the moment, I'm kind of just like doing as much core dev as I possibly can, and then whoever contacts us,
And that's a hell of a marketing. Like you stream every day, so
yeah, but I'm just streaming my dev. All right, all the memes are gone. That's good.
yeah.
Uh, okay, yeah, this is fine setting these mins. That's chill. Aha.
Is X streaming this laggy?
Yeah, it is.
Is it YouTube
It's
better?
faster. It's fastest on Twitch generally.
Twitch? Let me
Same
go to
handle.
Twitch because
Hmm.
let me switch to Twitch because like
Yeah.
that
No worries.
time difference is killing me.
Here, I can also stream it on Discord to you, so you can see what I'm doing.
Yeah, that will be better. Yeah. So that-
Actually, I can literally just turn my camera on, and then you get a live version of the stream view. Oh, but it's backwards.
Uh,
Okay, maybe I do my
it
screen
will-
instead. Is it backwards?
no. It looks fine to me.
Oh,
So
okay. Huh, for some reason it shows backwards on my screen. Alright, okay, you added this min. Uploaded train crashed 1B. Cool. And it
yeah,
looks like it's
happened like
very
several
likely
times.
we're gonna go back to 1B pretty soon because they
Uh,
just added this cool new feature, and I think Neptune is kamikazing their platform.
uh, okay. But like once like we switch to constellation, then yeah, no
But
one DB
Constellation doesn't
probably.
replace it doesn't replace like the web tracker. So Constellation is for like really large scale aggregate stuff.
Huh. I see.
It doesn't have
Huh.
like experiment management features or anything. It's basically like if you want to automate 20,000 experiments and see all the results together, then Constellation is good for that.
Ah,
If you want to
I
go like
see.
run 50 experiments and like pick out the details and like put different groupings of them and stuff, you'd still use a web interface.
Hmm. So like one annoying thing about 1DB is that it also sends the dashboard so that logs get bigger.
It
So like
sends the
for my
dashboard.
yeah,
Oh, that's
it
so
sends a
dumb.
dashboard.
I
So
think
so
you just
so
have
the
to make it so
log
it doesn't send standard out then.
yeah, because then each run ends up with logs of like 30 megabyte.
It
So
sends the freaking dashboard. That's so dumb.
so like it clogs up the like disk usage. It's like so
How
annoying.
does it even do that, dude? Like,
I don't know.
I print in place. That's crazy.
And
Oh, that's crazy.
yeah, like when you look at this, like my like G20 48 1 DB 1 DB, like look at the files and see the like file
Crazy.
size over there.
Yeah,
It's
that has to
bigger
not
than
be a
the
thing.
model.
This is just taking out means.
Yeah.
Only include. What's this only include?
So that sweep only, like so, like at the later sweeps, like I didn't like run sweep for 20 parameters. I just focused on 3 or 4. Yeah,
Okay.
just to find the parameters that doesn't crash my like 6 billion like training steps. So
Only include only fish. Cool. I gotta merge a couple more puffers into that. I have a couple open PRs for it.
I saw. Yeah, so like those changes relate to sweep. The sweep changes are related to like those long training runs. With that, like, I attached the picture in the PR that you'll see like a little bit different, but
Okay.
it's really focusing on finding like running rate or other clip coefficients that doesn't crash the long runs. So.
Okay, yeah, we can merge this. Why isn't this just one line? Like this could just be self dot like self thing. Oh, okay. Yeah, this could just be self thing. Whatever. It's a minor net. This is gonna put all the sweeps on the same GPU, man.
What do you mean?
So what happens if I run a multi-GPU sweep?
So that is where the Gaussian process now lives.
I don't know actually. So if I do 2 divisible devices equals 2 puffer train like puffer sweep, does this break?
I haven't tested it yet.
Yeah. So if you can test, I'll send you. Like something like that. It might relabel it. That might just get it relabeled, so it might work. Uh,
Any box?
you can run it on Tiny Box or whatever, yeah. But that would just, I would want to make sure that this does work with multi-sweeps. Because essentially the thing I want to do is I want to run a big multi-sweep for the baseline and then for Mingru on 2048. Like, that's what I want to do ASAP.
Yeah. Mm. So in that case, like what I assume is like so there's only one like sweep manager and it can produce like multiple suggestions, right? So you only need like one instances, no? Or how does it happen with
There are
multi-sweep? Like I
multiple
haven't seen.
configurations. So there is a mode for which it is one sweep instance for all the GPUs, and then there is a mode for which it's one sweep instance per GPU.
So like I kind of get it why you did it for the like previous like pyro version, but now like each suggestion takes like 1 or 2 seconds. There is really no need to have multiple sweep managers.
So that wasn't why I did it. The reason I did it is because there's a Pareto sweep mode. So I create a
Uh-huh.
sweep for a specific number of time steps. So every run is going to be the same number of time steps. And
Hmm?
because essentially the thing I want to do is I want to fill out a 3-dimensional Pareto curve for Constellation. And it is no longer
Hmm.
just cost in seconds and performance. It is now cost in seconds, agent steps, and performance. And I want to explore the full 3D space of that. And the only way that I could see to get that to work, I tested a few things. Maybe you have better success trying to do like just native three variable optimization. But the only way I could make it to work was to just sample 6 different time step budgets and then run the cost
Mhm.
optimal sweep for each budget.
Mm.
Yeah. And that's a big deal, right, with Constellation, because what we want to do with Constellation, the idea is, hey, we have Puffer really fast now, so can we just run a massive number of experiments, not like 200 experiments per environment, but thousands of experiments per environment,
Mhm.
and can we
Yeah.
understand fully, what is the least amount of compute we can spend, what is the least amount of data we can spend, and what does the trade-off curve look like across compute and data for this environment?
So
Constellation, the
there,
goal is to draw patterns. It's to draw patterns through everything, right? Constellation. And the key pattern, the most important one, I think, in RL, is this compute to data trade-off question.
there, like, yeah. Let me think about it.
So yeah, think about that a little
But
bit.
there, the issue is like when you have like set the CUDA 0,
Hmm?
then probably that like sweep manager will live on like, the same GPU
Yeah,
for
it
like
might have to
all.
just be, you might have to set the device to not be CUDA 0. It might have to be set to the same CUDA device as the current experiment. I don't know.
Let me see. Like if is that CUDA visible, then like CUDA
It might
0
relabel
becomes
them
that.
automatically, to be fair. I don't know.
Yeah.
But that is the objective of Constellation, for reference. It's a really cool thing if you think about it. But yeah, that's what we
Mm.
want to do.
Yeah, yeah.
What's this logistic
I'm with you.
regression?
Yeah.
Oh, you added a logistic
Success
regression for
classified.
success. That's funny.
Yeah. I mean, but it only like turns on for like when downsample is 1.
I see.
Very specific like use case.
I see.
Like, yeah, there like I was really focusing on like looking for stable hyperparameter that doesn't crash the run. Yeah, like
Yeah, we have to be a little
crowd.
careful. Yes, this makes sense. We have to be a little careful hard coding stuff like this because you can always, if you're just doing this on 2048, it's really easy to fit the sweep code to your problem rather than like making a general good thing. Um, so we definitely want to go test this on a bunch of M's to make sure it's good and stable.
Break and test Tetris works, so yeah.
Some good things, a couple good things to find, Kyung, would be, can we get the same like 27-second solves or faster on breakout out of this? So that's on the 5090. I think 27
Mhm,
seconds is record. And then
mhm.
can we get like the 3-second Pong solves?
I haven't tested on Pong, but like
Pong's really fast. It should be easy to like just do a
uh,
few of those.
okay, I can like just
Yeah,
pick up Pong right now, and you'll
that should
see
be
the
super quick.
breakout in this PR.
Yeah,
Yeah.
Pong, you can literally set Pong like a 10-second budget or whatever. It's super fast. Yeah, no, Pong is nice for that. And actually, one of the things I want to do is I want to see if we can do Pong in 1 second on Puffer 4.
A
Yeah,
lot of time will take more, I guess.
if we can just solve. I mean, because we're so fast now, we should be able to solve it in like one big gradient update or something.
Okay, picking up Pong. See.
Cool. Good work. I gotta get you into some low-level dev at some point, but like, this is all solid stuff. I'm seeing like how much cool stuff you're doing over here. But I don't know, maybe I'll let you have fun playing with the experimental things and I'll fight the CUDA demons.
Okay, I'll sidestep from Kuta demons for now.
It's okay. If you're interested in it, it is really cool stuff. But yeah, it does. I the C++ stuff I'm doing now is awful. The CUDA stuff is pretty cool.
Okay, I'll take that.
Yeah.
Probably looking for some opportunity later.
That's all right. I'm very happy it happened. I mean, this experimental stuff is super helpful. Let's see. I don't know. When I see people doing good stuff, I try to encourage people to try some low level dev because it was the single biggest mistake I made during my PhD was not getting into low level. Low level's
So
really
like
cool.
I start to have fun with like C code, like the environment code now. So yeah,
Well, I mean,
it
CUDA's just C that runs on your
grows.
GPU.
Yeah, that would be awesome.
That's all it is. It's literally C that runs on your GPU.
Mhm.
And it doesn't like if statements, but will run them anyways. Okay, can you explain to me how you're doing max suggestion cost? Because I added like this cutoff thing into training, where if a run just goes longer than a specific amount of time, it immediately is stopped. And I think you're doing something a little different, right?
So there, like, I is max suggestion cost in the training there too, or
Well,
no?
in my
Like,
versions
so
it
like
is. I don't know
it's
if you have it.
is it like is it in the 3.0?
I don't know. Might be. I know it's in 4.0.
I mean, like I didn't see any like that training like, stopping the
See
max
if it's not
suggestion
in here.
cost. So it's merely suggestion, right?
Let me see. Uh, so in here, you're correct that it is. I think in 4.0 I did it this way. It doesn't have to be done this way. But I'm actually curious on your thoughts for this. So, yeah, you see this?
Hmm. Okay. Then like that if
Well,
that
we
is
don't
in
have to do it
the
this
like
way.
sweet
I just want to know, like, do you have a way to prevent it from running like long experiments for a stupid amount of time?
uh
Is it this?
yeah, I would probably like try to make a like,
Or should
better
stop
version of
early?
that. Right now, it just checks if training is none, NaN,
Mm-hmm.
and it prevents a lot of like stupid compute waste for sure.
Yeah, so
But
that's
like
totally
I
fine.
think like uh another like a little step up would be, let's say like if the training has run for like 1 billion steps and the performance is like less than 0.01, then you can stop. So
Yeah, you need some
it
way of
just look
doing
at
this
the logs.
automatically
So
across M's though. Hmm. Okay. Well, think about that a little bit, because right now in 4.0, I just have it so that each env can set like a max experiment cost. Um, Probably we should do something a little smarter, like the asynchronous halving type thing, where they just kill bad runs early, right?
yeah, that's yeah. So that's that's an interesting problem, and like that's why I like start to like add that like should stop early. and
Mhm.
just preventing nans was a huge win. But then,
That's good.
yeah, like I can experiment more on that.
All right, cool.
I need a lot of sweeps too, so
Oh yeah, and you'll be able to run way more. You know, we can just do a ton of them on the big boxes. We might even buy some more boxes.
cool. Business is booming.
Well, they have a 8x 5090 box now. I'm gonna wait until I know. Like, I want to go benchmark Puffer 4 when it's done on all of the different
Mhm.
like GPUs out there to see how much faster it is in 5090s or 800s or whatever. And then if 5090s are really good, we could just get an 8x 5090 box for Puffer.
No AMD.
God no, I don't want to deal with that shit unless it works out of the box, but I doubt it.
Well, Tiny Corp will probably make a good driver out of it.
Yeah, but then you have to use TinyGrad, which is like honestly probably better than Torch. I don't know. I have to go look at some of their code more. Um, I think that they kind of did stuff the opposite of the way that I would want to do it, though, where they did pure Python and then it like
Hmm.
generates C and stuff. Um, I
But
I
you
guess they do
will
it that
just
way
go
for
directly.
yeah, but they do it because they want different to support different backends. But just having everything in Python and everything be code gen to me is just so gross. Like my happy place is just everything being pure C, everything being simple low level. Just so nice.
Oh, then how about like Mojo?
That thing is just not ever gonna catch on. And then like they did some good things, but then they also did some really stupid things for no reason. And like Mojo,
About
it's
the
it's
like a
also the same
CUDA.
thing, right? Mojo is also not like a low level. It's like a how do we do low
No,
level but make it look like Python?
it's like a Python superset they claim. So
Yeah, but the thing is, like,
anyway, like
pure
the
C is just good. Like, just C is good. It's like you don't need to
uh,
make C look like Python. You end up writing literally the same amount of
anything that
code.
works.
Like, I go port stuff from Python to C or like all the time, and I end up with the exact same amount of code in C, but mine's 100x faster.
Yeah, yeah, I start to feel that with the like environment work. So yeah,
Hmm?
everything is faster. That's cool.
What's sklearn here for?
Logistic regression.
Ah, that's such a heavy ass thing to need. Damn it. It's not in. I
I
guess it
mean,
wouldn't be in GPyTorch.
but it already has like NumPy and SciPy, so on top of that, it's like
I don't know
not
why
heavy.
we have SciPy, honestly. I think there's like one
I think
operation. I'd like to get rid of both of them if we can. Like logistic regression is like 4 lines in Torch, isn't it? Literally just like a one neuron with a sigmoid output.
GPyTorch needs SciPy.
Hmm. Annoying. Stupid heavy libraries. Okay, I mean this PR looks good though. Let's merge it.
Have a look at the like the figures. Yeah, I put it.
Oh,
Yeah, so
I like this.
like Tetris, and then the one is the like I'm looking for the, the stable hyperparams that doesn't break long runs. You see that running rate clip?
This is sweet. Hmm. This is sweet. Cool. Thank you. And then we have the giant ass
Hey,
PR.
not giant.
This is really, really good policy, though. one hot encoding for empty spaces, and each cell/tile.
Yeah, it works for now.
Heuristic rewards for tile states. Maintaining the snake pattern. Oh, that's really heuristic. Okay.
Yeah, that's heuristic, but like I try to not go too overboard with that. So the curriculum really like doing a lot of heavy lifting for sure. Yeah, just the heuristic viewers don't get you far.
Thousands. Many blessings from 67.
Hyper paradise. My son likes it. So. Halloween costume was about 67.
Okay, so this has the same thing in it, but that's fine.
Yeah, like those should be
This
the same like commit.
Do you remove the means from all the ends?
No, not all. I just
They
from
still run?
default. So. Really going overboard with 6-7. So. So like that's how I use sweep. I take the values from sweep as like the distance and kind of like looking at like seeing it as whether it is like robust. So like very small changes in hyperparameter, if it crashes run or change the result too much, then we are in a very unstable region. But like if I can just like round it and it works, then like yeah, we are in good place. So.
Yeah, we should probably do something for this formulae. Actually, it's one of the things I was thinking about with Constellation, is like the sphere of stable hypers. There's actually, so one of the things Constellation does is it'll go find you like all the M's that have a similar set of hyperparameters that also do well.
Yeah, and then that's what basically the Gaussian process regression is doing. It's giving you that like that Gaussian fit for each hyperparameter. So yeah, that's how I use sweep only and downsample. So Lord, many days of sleep over that. So
Over
exhausting.
this?
Of course, G2048. Yeah, haunting me.
Hmm.
Yeah, turning off all the curriculum and just let it evaluation.
Yeah. Yeah, for sure. You did it the correct way, though. I found a script like this from NYU, except that they were trying to do their evaluations with the C model.
What's the model?
Yeah, they were doing their evaluations. They were like trying to do something like this for eval time, but instead of using torch, they were trying to load like the really slow like one one
I see.
thread C model.
Yeah, like I started with that, but then yeah, I switched to that.
Yeah, this is better here.
Because like G2048 is like so long.
Mm-hmm.
It's like 30K, 40K ticks. Each run just it takes
Yeah.
like 5 minutes in C. So
Yeah. You did add a network. Wait, what? There's no puffernet included?
well, PufferNet that provides good components now. I build on top of that.
Yeah, but doesn't. Oh, I see, because that file's gonna include. Okay.
Yeah.
Fine. Fancy ass environment, but this is. Oh. Oh no, this is crazy network. Yellow, 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 yellow. Holy. Okay, I see your network. I have a theory, Kyung. So I know you got that
Mhm,
type of architecture from the robotics networks.
mhm.
I have this theory that the robotics net people are just kind of dumb.
I so yeah, yeah.
I'm gonna show
Let's
you
try
the
like
Mingru net in a second because I think it's a better architecture, and I'm curious to see how it does on 2048 versus baselines.
yeah, definitely. Yeah, so like that is like such a good problem now that we can test out the like model capabilities. And model
Uh-huh.
capabilities like really do matter because
Yep.
here with hidden 256, 128, they cannot like do this. So like those are the same.
Same thing, right?
Yeah.
It's just like
Yeah,
yeah,
I'm trying to
probably
yeah,
gonna
separate
conflict
it
or whatever, but we'll see. Yeah, this is the
the
same. This is the
same.
same. Cool. So I will merge this. We're gonna want this.
And you haven't seen
Oh, the
the
end. Duh.
actual
Oops.
game yet.
This is what happens when I know I need a break, but I have too much work to take a break.
Uh,
I was looking forward to getting some rest this weekend, and then I got like a super rushed contract job, so it's like, all right, for rush pricing, we'll work this
Business
weekend.
happen. Yeah.
Where'd the thing go? Can you scroll by it?
No, it will come later. Yeah, there.
Okay. Big PR.
New color scheme.
You know what I'm gonna be curious on, Kyung?
Mhm,
I'm gonna wonder if so when we do Puffer 4 and Puffer 5, right? I'm gonna wonder if we can
mhm.
get this result with less scaffolding.
That would be good. Yeah. So that yeah. So here now it relies on curriculum a lot,
Mm-hmm.
but then at the same time, it like for each amp to get higher tiles, you just need more ticks, like 30K, 40K. Like the agent has to go through that to even see the high tile.
So the cool thing is that's not gonna be true in Puffer 5
Why?
because we're gonna do state sets, state load, like state save, state load. So it's gonna be able to practice
Hmm.
like just the portions of the end that it needs. Isn't that cool?
Uh, that would be cool. Yeah,
Yeah,
that will probably
that'll do
replace
it, right?
the curriculum. Yeah,
Like that
that
will
will do
do
it.
it.
Yeah.
That's like the only thing you can do.
Then
There's no clever math you can do that would replace that. Because otherwise, you're correct.
No.
You're like, well, it
So
has to go through the whole thing just to see like the high level play once. The only way around
mhm,
that.
yeah. Okay. Then that'll be cool. Yeah.
Yeah, right. Cool stuff coming.
That's basically like a scaffolding and like a dynamic
Mm-hmm.
thingy. So that hard hand coding you see there.
Yeah, so you're doing something like that manually. But I
Yep.
think this will be a really good baseline because trying to beat this without all this like really well done scaffolding stuff is going to be a
Yeah.
hard challenge.
So like you were talking about Pokemon as that like ultimate challenge, and I agree with that. But like this like G2048 as much simplified, much simpler than Pokemon, but it's still long horizon. Like it's like 40,
Yeah, of
50K
course.
clicks.
It's very
So
hard to like intuit, right? Because you don't actually know over what subsequence you need to plan, for instance. Whereas Pokemon, there's like
mhm,
this really obvious visual exploration challenge where what you're seeing
yeah,
is not really similar. It's like they're like key differentiations, right? So like stuff like
yeah,
this and stuff like Go, it has that type of a problem where it's a really hard learning task, and we know that empirically, but we can't really understand why to the same degree that we can intuit like Pokemon or NetHack or like a full
hmm.
game. This is why games are
But
good, right? It's like because they're interpretable.
but the 2048 is a pretty in a sweet spot that yes, it's hard, complex, but
Mm-hmm.
it's very easy to interpret and see and fast. So
Oh
yeah,
yeah,
like a very good test bed.
this is a
Yeah.
very good test bed. I agree. Unique pattern. Yeah. Yes, this is all reward hacky, but that's fine.
Well, what like it's far smaller than Pokemon.
Oh, it's
Pokemon
obviously
was
going to
like
be less reward
heavily.
hacking than Pokemon. But then, how much reward hacking do you think Pokemon would have taken if Pokemon had run at millions of steps per second?
That's valid.
Right.
Yes,
Oh, also, I gotta
that's
answer
true.
this for Jess. So, how do you calculate end complexity? Kolmogorov. Okay, so this is Kolmogorov complexity. So you can see this is low entropy and this is low complexity, and this is medium entropy and high complexity, and this is high entropy and low complexity. So this is the one that you actually want. So if we could just measure this thing with Kolmogorov complexity, we'd be able to apply this to every environment. Except this whole thing is completely stupid because you can't actually compute this metric, and it just ends up being a massive nerd snipe. And literally, there's no better way to measure end complexity than subjective opinion of interpretable tasks. End rant.
Yeah,
Yeah, this
that
probably
was
took you some
really,
work.
really
This probably took quite a while. Solid end. We can get this PR'd in, and we can start running experiments on this. And I gotta show you one thing as well.
yeah.
I need this in 4, so I'm gonna have to merge this back to 4. And then let me show you one thing. This is the new. Okay, so this is a Mingru layer.
Mhm,
So this whole bit, this is the replacement for an LSTM. You can imagine that this
mm,
whole thing just here says LSTM cell.
mhm.
Here's the key.
Right. So
The skip connect and a norm.
ah,
And it seems like this lets us stack this architecture pretty deep.
That like residual connection.
So I'm thinking that instead of stacking, instead of having to stack a bajillion like linear layers in Gelus, I'm thinking this is going to be way better.
So like transformer is basically doing that, right?
So transformer is doing this quadratic scan thing, unless you have a linear variant. So this is kind of in between, because this is a recurrent mode. It's a state space model. So this is a recurrent mode. You see how it takes a hidden as an input, and then it gives you an output. So it like from t minus 1, it gives you t. It just turns out that the formulation of this specific recurrent cell, like I could write a for loop over this for training mode. I could write a for loop over t. But it turns out that mathematically, you can do this operation instead, and then this gives you the identical output, and you can do this in parallel.
So like was the parallel part in the paper too?
Yeah, so the parallel part's in the paper. It's not fully parallel. So the thing that makes it good is that it's this chunk here. So this is the only matrix multiply here, right? And this is done over time steps. So it's like an encoding op basically. And then there's still a portion that depends on time implicitly inside of this cum sum and log cum sum x. But you don't actually have to do like matrix ops over time. So this is a very small and fast operation compared to a matrix multiply. You get to batch all your matrix multiplies into one operation, and then only the gate has any recurrence in it, which is kind of cool.
So here, basically, like we can have the very like a lightweight encoder, and then like
Stack this.
and LSTM can be replaced with like a multi-layer mean group, and it will figure out. Like
Yeah,
so, like what we
like
are
this.
currently doing in transformers, right?
Yeah, except that this is way faster than any transformer.
That's so cool.
Yeah.
Yeah, really looking forward to it. Yeah.
Yeah. Now the thing that sucks about this is that for small models in Python, this is actually slower than Torch's really optimized LSTM kernel until I write my own kernels. And then when I do my own kernels, it's faster.
Yeah, should be.
No, it is. And
So,
then when you scale this, it's actually automatically faster than Torch.
so basically, it's a whole new architecture.
Yeah.
Like,
For Puffer.
yeah, that like we have not seen in RL. So,
Really has not been used in RL, yeah. Like, and it's kind of funny because I was kind of like getting concerned that this wasn't gonna work until I added the RMS norm and the skip connect, and now it works very well. So like basically, there's a ton of architecture work that we can do, and as long as we have the Python backend as an option, pretty much what you'll be able to do is you'll be able to fiddle with the Python architecture, like run a bunch of experiments and decide like,
yeah,
hey, I think that this is a good change. Why don't we port this into the C++ so we can have the super fast version? And like, yeah, we can just do that.
that's exciting. That's super
Yeah.
exciting.
And actually porting to C++ is not even hard. It's only the kernel ports that are hard. Kernel ports are hard. Because what I want to have happen is basically... So the reason that this can be slow is that every single one of these operations is a new kernel. And it's like they're just like sequential launches. Like all these operations are just new kernels, and then all these operations. So I can do this whole thing in one kernel. All fused. Pretty cool.
Yeah, that would be cool.
There you go.
So like the authors who like made Mingru, like in what context they've been using it? Is it to
Well, they
replace
just evaluated it
transformer?
on a few synthetic tasks and stuff, and then they got their paper rejected because reviewers were morons.
Yeah, I saw that. Like stupid
If this
reviewers.
actually works and we
But
end up keeping this for Puffer 4, I'm gonna write a thread on like how stupid this like open review is.
let me
It was
look at
completely
Minguru.
inappropriate too, because it was like third party authors of related work like coming into the open review to like bash on this paper during the review process.
Oh shit.
It was like completely stupid. And they're
Hmm.
like, oh, well, we already explored this in our paper, yada yada. It's like, your paper doesn't have code and your paper is shit. It's impossible to tell what the fuck you're doing. What did you have before Mingru? Just an LSTM, man. Optimized LSTM.
Hmm. So yeah, like with 2048, like I thought that like a 64 PPTT was like pretty small, but then like
Yeah,
if
so we
this
can go
can
bigger
like
now, which is
scale that
cool.
well, then
Yeah.
yeah, like that will totally crush this.
Yeah.
So
So because Mingru scales with time sequence way better than LSTM does.
hmm yep, yep, that's very exciting.
Hmm?
That's totally new game for
Yeah.
sure. Yeah. So like now you need 2048.
Yeah. So what I want to do, right, is I want to run your encoder with this as the backbone versus LSTM, and I want to see
hmm
if that works. And then I want to see if what happens if we take out some of those Gelus and we add more
hmm
stacks of this. And I want to
hmm
run full sweeps.
Yep, that's cool. Looking forward to it.
Hmm.
Yeah.
So we will do
So
that
so
after. The only thing I have to do at the moment is I got to finish Muon today, and then I want to
mhm.
like merge this into 4.0, so we can do that in 4.0.
so like the next step for 2048 is so right now I think it's already SOTA, like having 65K tile
That's
like
awesome.
15%. But then like people never have seemed to reach the next level, which is 132K
Hmm.
tile. that's that's like never like done before.
Hmm.
And if Mingru can like do that, then yeah, that's
Well, what do your learning
that'll
curves
be
look like?
legend. Oh, like, I
Can you
linked to
link
one
one?
DB. Yeah.
Yeah, link me one. I want to see if this is like, can we just
Are
run it
you
for
there?
longer?
Over there. Yeah. Over in the PR.
Oh, it's in, oh, duh.
Yeah. Full transparency. So there, like I told you about the
You can
aha
just run
moment.
this from
So
longer.
then like that's why I was like, looking for like stable hyperpara. Like
Yeah. You can just run this for like a couple hundred bill and it'll probably just do it.
maybe like yeah, but I already lost a lot of sleep over that. So
Yeah. We'll get some rest
I'm
first.
recovering. Yeah,
Some rest first.
and catch up with my actual work. Like I'm sorry.
Yeah, you should do that. You're doing robotic
I mean,
stuff
this
now, right?
was fun. Yeah, this
Yeah.
was fun, but yeah, like yes, to get that next level, like 132K, yes, we need longer training, like that stable longer training, and yeah, better architecture helps. But
Hmm.
like really, like having to get you have to roll out for like a 50K steps and like multiply by like a number of m's.
Yep.
You just need more steps.
Yeah.
So I think that that'll be a great like target for Popper 4.0, like 132K tile.
We can try it. The curriculum implicit like the state set things is not going into 4 though. That's gonna be Puffer 5.
No, without like a state set. It's just like a longer, faster training with
Mm-hmm.
like a mean group reaching 132K tile
Mm-hmm.
and with consumer hardware. yeah, like that without search, like all previous solutions were using search,
Hmm.
so they were making 1 terabyte of
Oh my
lookup
gosh.
table,
Terrible.
and then they were reaching 6%, 65K. But now we have like a 14 megabyte weights
That's
that
awesome.
can like crush that.
Should write an article
But
on this, man.
then,
Hmm.
uh, yeah, yeah, like work first. Yeah,
Work
don't get
first,
me
yeah.
fired. But but like 132K tile with very small network that runs in hours, and yeah, like that's like yeah, that will be golden. Yeah, for sure.
This is gonna be very cool. I mean, this is already very cool. Um, I mean, you have this
So
result
I think
already. Like, this is technically really like a Puffer 3 result in the sense that you're really
yeah,
using Puffer 3. So, like, we can even then see how much better we can do with the Puffer 4 net and
yeah,
speed ups and
yeah. I
everything.
totally agree. This is as far as Puffer 3.0 can
Yeah,
like push. And then like the next level puffer will have to go beyond that, which probably will with the speed and like better architecture. So
puffing
yeah,
up.
2048 was like pretty awesome test bed for like many reasons. So
Yeah,
I
this
mean
is crazy that
breakout,
you have like a curve
Tetris,
that goes like the curve keeps going up for billions with a problem like
and
this.
then you see that the clear aha moment there. Like yeah,
Hmm.
like that's where the scaffolding curriculum and then the end game the practice meet when you look at the curriculum the training curve I go back,
Kind of
so
funny that this
you
is
will
like
see.
implies 2048 is harder than driving.
So here like the max tile has been the capped at 32K, right?
Hmm.
The agent have not cracked the end game yet, so it was like keep bumping to
Mm.
the very last tiles. But then once the agent start to crack the end game, then it just goes up, right?
Yeah, I've seen
So
stuff
that
like this happen before as well. Like this can happen in complex M's for sure.
mhm.
Cool.
So there like showing that was like pretty like exciting. I lost a few sleeps over that. Yeah,
Well, get sleep. I generally
but
suggest
yeah,
get
that was
sleep,
so
get
fun.
exercise. Work hard, but get sleep, get exercise.
But that was so exciting. Yeah, very exciting 2 weeks for sure.
Uh,
Uh,
I've
that
just
like
been fighting
when
Torch.
that scaffolding and end game matches it clicks and then it explodes. So
I've seen this type of thing in Neural MMO before, as well.
mhm.
And like, yeah, I think it's pretty cool to see this out of like 2048. You'll probably
Yeah.
see it again at
So
131K.
yeah, probably. Yeah, definitely. Like when it starts go over that like next 65K
Yeah.
barrier, yeah,
You actually should
that will
see
be
it.
golden.
You should technically see multiple of them, like multiple spikes over here. But it's like it's just the optimizer is so good that it just smooths this out. So actually what you'd expect is with a better learning algorithm, you wouldn't see this spike. It would just be smooth. And then the spike is only
So
gonna
I
occur when it's like really at the edge of what the learning algo can do.
yeah, so I think that is like little happening around 10K, which is like a 16K tile,
Like here,
and
right?
it's kind of like smoothed it out, right? So yeah,
Yeah. Yeah, that makes sense. And then this whole front bit is smooth, yeah.
yeah, whole
Like
front
below
bit is like
16K.
already solved.
Hmm.
That became so trivial. So like shooting for 32K and
Yeah.
then
And
shooting
that's
for
already like way
65K.
above majority of humans
Yeah, of
immediately.
course. Yeah. Like
Soda
just
puff.
like try to watch it play for once. Like yeah.
Oh, we can get it
Are you
onto the
going to
website.
yeah, like Tetris and
It'll be
G2048,
super
like
fun to
when I
watch.
locate them. Yeah. It's I tweak the games so that it's visually pleasing to watch. Like I
Mhm.
yeah, Tetris was so boring, so I made it harder. So
Hmm. I think that what I should do at some point is I should just have like a one-screen dashboard with Ocean, where you can just click like the dashboard and just have like all our coolest M's on one screen in real time. That'd be super
Yeah,
fun.
yeah, a few of them. I mean,
I mean, Neural MMO is cool. Impulse Wars, if we had a good policy, would be cool. Driving is cool. Couple of the arcade ones, like if you just render them small, are cool. Tetris 2048.
yeah, I suggest to update the website ASAP. Like that will be,
Hmm.
and that people watch like 2048 through your like act. So
Mhm. Yeah, this
people
is the
like rarely like have seen that like 65K tile because it takes hours to get there. So
yeah.
in YouTube, when like you watch human play or the
I mean, I
stupid
could just
agents
10x the
play.
speed.
So it's like 30 hertz now, and then yeah, well if you do 60 hertz, yeah, maybe. Ah, yeah. Huh?
Like, is it too still inefficient? Is it still too inefficient? Yes, dude. Obviously, it is.
Ah, okay.
Like,
Yeah, that Tetris is a previous version, and it will die on 10K. So
yeah, this
yeah,
one.
yeah,
It's already. I think this one's probably better than I am already. At least with these
it
controls.
is.
Maybe with cleaner controls, I could do about this well with a little practice. But it's pretty good.
Wait, is it the new Tetris or no?
No, this is
Like
the old
why
one.
there's a yeah, yeah, yeah. I thought the below lines were garbage, but then
No, it's
yeah,
just like done
it's
stupid
that
shit.
the agents were dumb. Okay,
All right, cool.
yeah, update both games. That will make me happy.
Okay, cool. I'm gonna try to get them ported over. Get everything to 4.0. I'm gonna run some baselines, and then we'll get this onto the website. It'll be fun.
Yep.
You sure you want 2048 on the website before you have time to write a post? Like, you should write a post on that, man, if you have soda on it.
I don't know. Whatever.
All right. Okay.
Yeah, just like mention me in the PR, and then that will do. Yeah.
Will do. Okay. I'm gonna go see if I can get Torch to behave.
Cool. So like yeah, so basically this is where like Popper 3 will took us, and then yeah, go Popper 4.
Well,
Yeah.
you still can run this technically. You could just 6 GPU this for like 200 billion steps, right?
Uh, nah, like that. Let
Nah.
me catch up on work first.
Yeah, okay.
Oh.
All right. Go get some work done and we'll catch up in a bit.
Alright, cool.
Thanks, Kyung. Bye.
Bye.
That was fun. Kyung does good stuff. We go back to fighting Torch. Okay, so did this add Muon? Okay. All right. Uh, Jung says Pong solves in 5 seconds on a 4090. Fuel. That's a fast sweep. Oh, let me go check one email. Oh, I had to read and sign one document, guys. 1 second. Just reading this document real quick, 1 second. I have to ask them for I have to ask them for one last thing and I will be on this. I just have to make sure. I gotta make sure one thing and then I will be back on this. Hang on. Sent one message. I'm good. I just needed to request. I needed to read a contract and to do things. You read it, chat at all? Yes, Miles, I do. I had to do. I had to read a document off on my other monitor for a second. Why use a recurrent model for Markovian M's like G2048? It's just standard, Meister. Like, technically, it's nice for your models to be able to remember stuff, and like alternatively, you'd have to come up with a different architecture stack for recurrent and non-recurrent, and we can just make this model fast anyways, so there's no point in not doing it. And oftentimes, M's that you think are Markovian actually aren't. In this case, it definitely actually is, but you could very easily mess it up as well. Okay. All right, what's wrong with Muon? It's probably this, right? Humans are potentially able to extend lifespan up to hundreds or thousands of years. Do you think there'll be some issue regarding memory? Not appropriately or efficiently managing our memory. We don't lose the ability to write stuff down, right? I mean, yeah, we rediscover history every generation. Like, if anything, this makes that less of a problem, no? And I suspect we won't just extend life to hundreds or thousands of years. I think we'll just, like, stop aging entirely. That would seem more likely to me. Would be awesome. Oops. Ah, this needs to go in here. Better damn well be in our lifetimes, man. Spend so much damn time on science, I'd like to have some time to enjoy as well, thank you very much. Not that I don't enjoy this, but it's a lot of work. I don't know, I think RL will have a part to play in it. In the sense of, like, simulation is one of the best tools we have for discovery, and RL is going to make simulation a way better tool. How do I edit one header file? And it has to rebuild 102 files at, like, 2 files per second. That's disgusting. Why is it not showing your messages on... My chat broke or something. Do you feel responsibility to do it? Yeah, yeah. I mean, it's like... It's more I just get... I'm so annoyed, like, at the state of tech. And, like... I mean, in a remotely optimal world, you basically wouldn't be able to do anything as an individual that's valuable that, like, a company with billions of dollars hasn't already done. But, like, the fact that I can just sit here and solve outstanding questions that have just gone unsolved that are valuable and important for a decade is nuts. So as long as this is the state of the world, like, yeah, I'm gonna do my damnedest to fix shit. I mean, it's truly insane, like what I've discovered in the last couple of years. I've just blown past everything, like this whole state of RL as it was when I finished my PhD. I've blown by it by a factor of like 100 to 1,000 in 2 years, less than 2 years. That's kind of nuts. And like in another 2 years, we're gonna have this entire field like stable, solid, mature, working out of the box. It's pretty clear, all laid out. It's just a lot of work. That's kind of the idea of this stream, right? Is it's like watch crazy research progress happen live. Do you work with others? Well, yeah, I run. So Puffer's a big open source project. It's the fastest growing one in this space. Like, this is when I started working on it full time right here. And we've got like 2,500 people in the Discord. We've got dozens of environments, most of which are by contributors. We now have, we have company contracts as well. Our LVR is bad because of LM. They're symbolic. I just ignore that whole thing because it's too that whole area, it's too slow to make any progress as an individual. Like when I'm doing this stuff, I can make crazy sci-fi tech out of nothing. I think this recognized Muon, didn't it? Interesting. Heck is wrong with this, man? I have it here. What if I do this? That should tell me, right? If it's there or not. Probably just linking against the wrong torch. Not fundamentally different from games. Well, we can just use games, dude. Just don't do games on frickin' pixels. Because it's slow as shit. So it's gotta be... Oh, does it actually go to... Really? It goes to cafe too? Yes. Is that an error? I see. That I can actually fix. Torch Optim Atom H. There we are. No maintainers. This one was funny to me because there's this one guy, unless it's a bot, but this doesn't look like a bot. That's funny. Yeah, no, it's just not like Arc is not actually AGI at all under any useful definition. Oh, Francisco posted the dumbest shit earlier today as well. What is it, friend? Let's just do this. Which makes sense because Karas. This is literally the opposite of how you do things. Literally the opposite. This is how you fuck things up. Alright, can we do this? Oh. So, what happened here? Eh? Oh, I know what happened. I'm dumb. Ah, man. Compile torch with Lapac. Well, I mean Karas, right? I gotta find more like good, well-built software projects because it kind of starts to lose the sting when I'm just like critical of every single piece of software ever. But it's just truly the case that there are very, very few things these days that are just truly well built. Then expand your thought on the post a bit. You discover things by like peeling back stupid layers of abstraction and like wrong mental models and wrong, wrappers that people have built up more than anything. Discovery requires clarity. Abstraction is the opposite of clarity. Because, like, oh, in theory, they let you think about things from a high level, but in practice, it just gives you, like, they're never done correctly. They're always wrong. Like, the way to do them is to not do them because you never get them right, anyways. Why do I have to do this shit? Can I just, like, go real quick? Why the fuck is this getting called again? Policy. Eh? No. God damn it. Why the fuck? Why did it do this shit? Dude, that's so lame. Hello, welcome. That's so obnoxious, man. That's like so incredibly obnoxious. Get development experience, man. Okay, what do I do about this? Test it on CPU maybe? But that's like, no, I need this working on GPU, man. Like, fuck. Udin MKL. Super obnoxious. Get torch to build. Well, now it's doing things at least. Cool. I'm gonna use the restroom real quick. And hopefully this does a thing. I'll be right back. One quick set. The heck happened? Dash dash version. What the hell is this, man? Where's the fucking error? Oh. Lovely. Still? Fuck. I don't want to fucking do that. Thing. PyTorch driving me crazy. 1 hour to actually write a feature. 2 hours trying to figure out why the fuck the project doesn't compile. Lovely. Okay. Hopefully that works. Is it 170? Something like that. That's a nice setup. Hmm. What am I supposed to do other than sit here and, like, wait for PyTorch to finish its bullshit? Like, I just need this thing to be done today. That's basically the only thing. I guess we can do this. Function. And let's see. Not. See. Okay. Cool. Okay. Oh, lovely. Yeah, Torch's mid compilation is not gonna work. Fun, 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 fun. How's everybody doing? Love waiting for Torch to compile. What machine do you runs on locally? I got a desktop right there with a 4090. Pretty similar to the machines I have back there. This is why C++ is evil, for reference. Like, what the fuck? We're compiling 1 file per second. 1 file per second. How? These aren't even real files. These are autogen files. Funny. Let me think in the meantime. So, the plan here is pretty much just to test. Let's at least get our params loaded into this thing, I guess. Yeah. What params does Muon take here? Entropy, betas, epsilon. That's all we changed, right? Yeah, learning rate, beta, epsilon. I didn't mess with momentum. Yeah, I guess it is just this, right? So it's kind of weird to have same learning rate like this. I guess this is what I'm doing now, though, no? Yeah, this is exactly what I'm doing. Oh, match RMS out of W, right? That's important. Yeah. Alright, so that's what it's gonna be. Hopefully this actually builds with proper architecture support. I don't know, has anybody else ever done, had to get Torch to build correctly? I had it almost there, but then, it built with the wrong driver support, wrong GPU support. What is that technically wrong? Wrong CUDA support, right? Yeah, wrong CUDA architecture. If this doesn't work, then what I'm going to do is I'm just going to hack it all real quick to run CPU. Because I'd like to get this PR in today if I can. That'd be great. I should have probably checked that nobody's been doing this, actually. That would be really stupid, right? Come on. Yeah, nothing. Well, you know what we'll do in the meantime instead of just like sitting here not even thinking. I think what I want to do tomorrow is I want to figure out how we can have backends for all the C++ M's. And there are two things that are just awful about this. So let me talk through these now. The first thing is that you're writing in C, and this is kind of one of those rare cases where like you genuinely need to void star a bunch of stuff, because if it's going to be like vector step or whatever, vector step is going to have to be like void star, um, which I guess is not terrible if I think about it. You know, it's not terrible to have it that way. But then the other thing that's just really gross, I suppose, is how we do the initializations. Right? How the heck do we even do that? Can C read? Well, no, there's like an ini file library maybe for C, but that's still super obnoxious. Hmm. So, I mean, if we can pass params over... Ugh. Yeah, that's the hardest bit, actually, come to think of it, right? Is how on earth do we pass environment parameters from Python? Everything else is not bad. That's disgusting. I guess, honestly, our env binding thing would be the way to go, right? This is giving me a bunch of garbage. I'm trying to think how you would do this in C. So, like, you have some parse script for your file. Just write a big if statement, wouldn't you? Well, no, I can do it, right? I can just, it's going to be slightly annoying, but all I'd have to do is I'd make like a create. Yeah, I'd make like a create function. Still a little hard. Is it? No, it's not, because what you do is you'd have, yeah, you just have each thing, it would just define its own init method, and it would have to have like unpack from a dictionary type object. That's fine. That's fine. So like the init method is just like slightly more obnoxious, but that's genuinely like okay. Init from args or whatever. I can figure that out tomorrow for sure. Multiprocessing or multi-threading. In general. Static buffers. I was just wondering if there are any gotchas, because I didn't actually know about the static buffer thing. I never used that keyword ever. Yo, Cerberus, what's up here? These have to be bots, right? There can't be actual 3 real people who didn't get the joke, right? That's cool. That's very cool. Okay, so there's some functions that do this. Ooh, thread safety on Rand. Cool. Custom PRNG. Cool. I didn't think of that one, but that makes sense. This is kind of insane. Why do I have to compile all this crap? Lots of reply guy maximalist. And I get baited into replying to a bunch of dumb stuff, but like, holy. That's crazy. Yeah, I don't know. It is absolutely the case that if Google's gonna point a fuzzer at your library and be like, we need this fixed immediately, like, you should at least throw some sort of sponsorship. Like, in the scheme of things, these open source libraries are very rarely asking for very much. I mean, Puffer's kind of the exception in that case where it's like, I absolutely go fuck you, pay me. Like, all my tools are free, but if you want, like, support at a company, then you get a big contract. I gotta love how in order to just, like, test my basic thing, we have to spend an hour compiling every possible version of fucking flash attention. Patents and stuff? Nope. Patents aren't particularly useful unless you want to be a legal company. It's very simple, right? It's like you can go try to solve your hard RL problem on your own, and you'll be in a way better position to do that with Puffer than otherwise. But I've seen time and time again, people have large teams and they mess it up, even with all the tools and even with all the documentation and stuff that I put out there, and even with like us literally having brand new programmers doing it. So we charge in order to build custom sims and to make sure things are done right. And you will end up spending a lot less hiring Puffer than you will be doing trying to do it yourself. Is Torch a mess? Yeah, it is. Man, Torch is, ugh. I mean, it's really, I just don't like C++ at all, to be fair. But, like, then also this compilation shenanigans is just a nightmare. Like, I shouldn't be spending an hour waiting for every possible version of Flash Attention to compile. Actually, that's a great... I mean, it's literally, I'm here for an hour waiting for fucking Flash attention to compile, and I gotta hope that the architecture is right, otherwise it's gonna have to do it again. And fuck, if it's not good for, if this doesn't have SM89 in it, then I guess I'm just going to do it on CPU, and then wait for it to get into a nightly build. Because, like, what the hell, right? Like, people complain in PufferLib that I have it so that it compiles all the environments every time you compile one environment, which takes like 20 seconds or whatever. So like I'm adding an option so that you can just compile your one environment, right? Because people didn't want to wait the 20 seconds, which is completely fair. And then here, Torch is like, nah, bro, give me an hour. Give me a whole freaking hour to compile. Look at this. Flash Forward Split, HDIM 160, BF16, SM80. And there's HDIM 192. And there is FP16, HDIM 160. Ah, yes, everybody's favorite hidden dim, 160. I'm not even using any form of attention for fuck's sake. Hopefully, I mean, let's start the PR at least. Alright, wait. Is there a way to do a draft? Hello, Lucky, welcome. How's it going? Uh, Let me also go check my email because I need to see whether I am starting client work tonight or not. Oh, perfect. That's one other thing I can do while I wait for this. Hang on. Copy. Let me just make sure I have this invoice correct. I gotta send one thing. Compiling shit anyways. That would be bad. Let's not leave the other client's freaking name on the invoice template. Eh. That better not be an error that I see on the side of my my vision there. Cool. Okay, so this says that we have torch. But do we really have torch? What the hell? Oh. It's kind of funny to me that there were like literally 3 people who didn't get it. Or our bots, I guess. What the hell? Where is error? Optimizer? Ah, I see. Oh, let's not mess with that. Eh? What'd I do? What'd I do? What'd I do? Ah. Weird thing. Uh-huh. Nice. Now, are we lucky enough to have it work with orthogonal? Kaboom. Nope. Well, you can't have everything. We'll go no orthogonal. We also need to add the skip connects, right? So this actually does do kind of something. Use the skip connects. So it's going to be after out, you just add out plus x, and then you do norm. Out equals out plus x, x, x. Like this, right? Oh, there better be RMS norm in C++. Come on. How much stuff is left out of there? The kernels. Does it need a weight? Wait, does this have any learnable parameters? Hey, Jess. Suffering. Ah, there it is. How is there no RMS norm in C++? Like, come on, man. Oh, that's so obnoxious. Well, I have to go get dinner soon, so like, guess we're not gonna get RMS norm in today. Do this at least. Optimizing. Not really well, but it is optimizing. Get a draft PR in at least. It's not bad. Not discard commits, right? Hang on. I just want to make sure I didn't click the wrong thing. Yeah. Perfect. They're submitting a change. I can still make a draft PR, right? Isn't there like this mark as draft thing? Quest. Why does it not have this button? Oh wait, hang on. Pull request. Where's my UI on this thing? Actually, I can just do. Class. Pull request. Why is there no... I'm so confused. Come on. Why is my UI different? Am I in the wrong? Hours spent writing actual code. Much more than hours spent on bullshit. Okay. Oh, here it is. After pull request. Cool. Further contributing guidelines. Okay, and I gotta run in a few minutes, but let's see what I missed. So we do Python test port. Ah. Okay, this is failures equals 3. The heck is this? Test index add correctness. The heck is this, man? CPP warnings have Python context. Okay. See what else I changed in this PR. Nothing. Nothing. Cool. All right, I gotta go in a second, folks. I'm gonna have some client work to do in the evening, most likely. So I'll be back all day tomorrow streaming. Puffer.ai for all the things. Start Puffer on GitHub. It helps me out a ton. Discord if you want to get involved with dev, and follow on X for more content.